In this video, we will talk about sustainable ways to irrigate your plants. Before we start, if you like gardening, make sure you subscribe to this channel and hit the like button. We post gardening tips and hacks every other day. We all know that water is a key component of a plant's growth. Water, along with sunlight and carbon dioxide, are reactants in photosynthesis, the food-making process. Although the global water crisis is undeniable, surprisingly little effort is being made to promote, develop, and understand more effective, low-cost irrigation systems. Drip is considered the best option, although it is unsuitable for rural areas with limited technology and unfiltered, unpressurized water supplies. The techniques we've outlined will work effectively and use less water than drip irrigation. It is also a good idea to capture and use any rain that falls. To begin, collect rainwater in cisterns using catchments and hard surfaces. Then use micro-catchments, pitting, swales, and imprinting to save as much water as possible on the land. Of course, keep an eye out for dams in the gullies. If you have mulch, compost, or brush pieces, use them. Available alternatives. Bainbridge in 2014 experimented with and tested a variety of old cultures' alternative systems, as well as developed new techniques that perform effectively while using far less water. In most cases, they also limit weed development, reduce disease issues, and increase productivity. Many of these systems may be unfamiliar to you, so let us get into them. Deep pipe irrigation. Deep pipe irrigation concentrates irrigation water in the deep root zone by using an open vertical or near vertical pipe. Grapevine weight on a deep pipe drip system was more than double that of surface drip and more than 6 times that of normal surface watering, according to experiments in Africa. Deep pipe has proven to be the most successful solution. To keep lizards and animals away, use a 4 to 5 cm diameter plastic pipe planted vertically in the soil 30 to 60 cm deep near the seedling or tree with a screen cover, 6 mm screen. Silicone caulk or polyurethane glue can be used to adhere them. On the side of the pipe closest to the plant, a series of tiny holes should be placed evenly. To get the alignment perfect, make a mark at the top using paint. Bamboo with nodes cut out also works, but wrap it in a few rounds of twine or wire to keep it from breaking. Low-quality water can be utilized for deep pipe irrigation. Without significant support systems, it is feasible to put up using simple materials and unskilled personnel. Pressurized filtered water is not needed. The deep pipes allow for more efficient water usage, owing to less evaporation and weed control. They also allow water to be sprayed fast and effectively on steep slopes with minimal runoff waste. Drip emitters fitted in 13 mm pipe were also highly successful in deep pipe irrigation. This allows for deep watering while also making it simple to inspect and repair emitters. Drip irrigation and some aftermaths. Drip systems use an excessive amount of water, generally 2 to 4 liters per emitter each hour, and thus necessitate controlled water pressure and meticulous filtering. Furthermore, Bainbridge, 2007, discovered that many animals will chew tubing, also known as spaghetti tubing, and pipelines even when there is open water nearby, including coyotes, rabbits, and dogs. In a study conducted by Bainbridge, 2007, all of the spaghetti tubing was chewed up before the plants were attacked, even though they employed repellents to protect the seedlings. They have also put repellents on the tubing, but they have not worked. Sediment and salt may readily fill the emitters, and numerous bug species can also plug them. Drip systems are also vulnerable to vandalism, and repairs can be expensive. Wick irrigation. Wicks, whether capillary wicking, slow, gravity-supplied, moderate, or pressured, rapid, appear to be extremely promising. The greatest nylon wicks have been created from woven, not braided, cleaned, and weathered nylon or polyester rope. You can see if they work by suspending them in a pail of water with some food coloring and watching the capillary rise. The flow rate is determined by the system and wick. Gulf rope creates an effective wick rope for herbicide spreaders. In an extremely hot and dry environment, A Palo Verde seedling in a bucket of 16 grit silica sand needed just 20 to 30 milliliters per day. Buried clay pot irrigation. Buried clay pot, a la pitcher irrigation employs the use of a buried, unglazed terracotta clay pot filled with water to give a constant supply of water to surrounding plants. The pace at which water seeps out through the walls of the buried clay pot is influenced in part by the amount of water required by the plant. The irrigation efficiency is particularly high as a result of the auto-control. Any precipitation that does fall can be stored and utilized by using coverings that catch rain. Irrigation alas are becoming more common in the United States, but they are still uncommon. If the bottom hole is sealed, most regular red clay garden pots may be used for irrigation. Rubber stoppers or corks perform better than silicone caulk or epoxy. Irrigating cuttings in the nursery or in the field with buried clay pot irrigation is also extremely successful. A sealed pot is put within a bigger pot in the nursery, with the drain left open and sand or potting mix between them. The inside container is filled with water, which keeps the soil wet. Porous capsule irrigation. Irrigation with porous capsules is a contemporary version of buried clay pot irrigation. In Australia, wet pots are now available. A fantastic system. Unlike buried clay pots, porous capsules are easier to connect to a piped network. If you can't find them, you may construct your own by gluing together clay pots or pots and pot bases. They have worked well, but they're more expensive to manufacture and install than buried clay pots or deep pipelines. Porous clay pipes buried underground are comparable to porous capsules. It is difficult to find porous pipe, although it is available in Japan. It's also possible that old drain tiles will suffice. Water consumption was decreased by 80%, chemical fertilizer use was cut by 50%, and maize yields improved by 83%, melons by 48%, and potatoes by 34% in a study using buried porous clay pipe in France. Porous hose irrigation. Irrigation components for porous hoses are widely accessible and save water. However, vertically arranging pieces of porous hose like a deep pipe is far more efficient. It's necessary to use a low-pressure hose. This may be attached to a water bottle or a tank with a distribution system. Vertically mounted 30 cm long 1 cm diameter porous hose trials showed promising results. In extremely windy locations, a triangular arrangement of porous hoses can be utilized to generate wind stiffness. Perforated pipe. Perforated drainage pipe buried beneath the earth can function similarly to a horizontal deep pipe. The installation of windbreaks in the Mojave Desert has been highly effective using this 10 cm slotted drain pipe. One run is nearly a kilometer long. A water truck fills vertical standpipes with screen coverings at roughly 100-foot intervals to irrigate the plants. According to the slope and flow direction, filling risers are connected to posts at regular intervals. Micro-catchments. Micro-catchments are shaped with slopes and berms to enhance and concentrate rain drainage. Rain infiltrates and is effectively stored in the soil profile after draining into a planting basin. What's fantastic is, micro-catchments are easy to build and cost little money, and they may be done quickly with local materials and labor. The runoff water has a low salt content and is very cheap because it does not need to be carried or pumped. Micro-catchments improve leaching and, in many cases, lower soil salinity. The main disadvantage of micro-catchments is that they only operate when it rains. In the Mojave Desert, micro-catchments increased transplant survival and growth. A better choice is to use micro-catchments with irrigation. However, deep pipes or porous capsules may be the best option. Waffle gardens. Planting in depressions with compacted pathways between tiny portions improves the plant's environment and catches additional rainwater. Rocks can be used to line the pathways. Go and try what's best for you. All of these solutions are inexpensive and effective. Try them out. To prevent wind blast and gnawing by animals and insects, plants should be given a tree shelter or a fence, if available. Even in harsh desert circumstances, these innovative and little-known irrigation methods may substantially boost plant survival and development. If you are looking to start your garden, check out the links in the description for our recommended books and audiobooks. Don't forget to download the free ebook too. What do you think of our tips? Let us know in the comment section below. If you enjoyed this video and want to hear from us again, be sure to hit that subscribe button before you go. Thanks for watching.